Welcome everyone to this video. So we have a question from the HC Verma. Question is from the solved examples. A charge of 4 into 10 to the power minus 8 coulomb is distributed uniformly on the surface of a sphere of radius 1 centimeter. So we have a sphere whose radius is 1 centimeter. It is covered by a concentric hollow conducting sphere of radius 5 centimeter. Find the electric field at a point 2 centimeter away from the center. So at this point, what is going to be the electric field? And then in the B part, some charge is placed 6 into 10 to the power minus 8 on the outer sphere of the hollow sphere. What is the surface charge density of the outside sphere? Charge placed on the inner sphere is 4 into 10 to the power minus 8. Cool. So here basically whatever electric field is because of this sphere, only that will be counted at this point because outside charge does not count. So electric field at inner point, let's say this point is some A, at A simply K Q N divided by a distance that is 2 centimeter squared. So this is 9 into 10 to the power 9 into 4 into 10 to the power minus 8 divided by 4 into 10 to the power minus 4 hence per coulomb. So this is some 9 into 10 to the power 1 plus 4, that is 9 into 10 to the power 5 volt per meter. So this is the electric field at point A. Now if a charge of 6 into 10 to the power minus 8 coulomb is distributed on the outer sphere, if this charge is Qn, this gets induced minus Qn in the inner sphere of the concentric shell, and its opposite charge plus Qn is distributed at the outer sphere, equal and opposite charge. So its final value is some 10 to the power minus 7 divided by 4 pi coulomb per meter square. So thank you for joining. Have a good day.